So by following the steps that we've been following, these are the values that hopefully you got for the x-intercept, the value of A, the y-intercept, the axis of symmetry, and then the vertex coordinate. Okay, and if you'd like to practice this more, which I recommend, you can do these textbook questions. And sorry that this is a new video. The Microsoft crashed and got upset with me, so I had to restart, and this will be a new video, so we'll go into our 7.5 and 6 notes in here too. Okay, so we talked about how you can have a parabola can have one root, two roots, or no roots. So let's look at what it looks like if it only has one root. Okay, and what will happen is, here you see that in our factored form we have x minus r and x minus r. So it's the same root because the factors are the same. So then we only have one root. So if there is only one zero, or to put this into written form, if you factor an equation and you have the same factor multiplied by itself, so 1 times 1 or 2 times 2 or 6 times 6, then you only have one root. So if we look here, and we want our factored form, we'll have y equals a, and then if we look at, here is our one root, so our root is 3, so it's 3, 0. So then our written out, it would be x minus 3 and x minus 3. And we can also say this as x equals a x minus 3 squared. Now, of course, we'll want to find a. Now, normally we would choose our y-intercept, but you can see that we can't see our y-intercept on this graph. So then we can choose any point that their coordinates are clear. So here you have a 2, 1, and the other one I see that's really clear is up here is 1, 4. Any point that passes exactly through an intersection of coordinates is fine. So I'm going to use 2, 1. And I'll fill in those points into my factored form. So I'll go 1 equals a, and I'll go 2 minus 3 squared, 1 equals a, negative 1 squared, 1 equals 1a, so a will equal 1. And my factored form will be y equals 1x minus 3 squared. That's factored form. And if you didn't want to put the 1, that's fine. To write my standard form, and remember that standard form is ax squared plus bx plus c. And I'm going to have you again pause the video, try to write this out yourself, and then start it, and my solution will be up. So to move from factored form over here to standard form over here, you just have to expand everything until you get your ax squared. Moving on in the notes, we're going to look at solving quadratics by factoring. And we saw this a little bit, but we're just going to look at it a little bit more here. So to solve a quadratic function means that we have to find the roots. Okay, so when I say solve a quadratic function, I want you to find me those roots. Okay, so the r and the s. Or if it's only got one root, then the r and the r. So you can have 3 general forms. So you can have the general trinomial where x equals 1. Okay, and this is quite common, and it's the most straightforward to factor. And you can have another trinomial where x does not equal 1. And then, so you could have 2 or 3 or 12 or whatever. And then you can have something called the difference of squares binomial. So you'll notice that 25 and 64 are squares, which means this is 5 times 5, and this is 8 times 8. So other perfect squares would be 9, 16, 36, things like that, because this is 3 times 3, 4 times 4, 6 times 6. So anything that, when you see 2 perfect squares, we call that a difference of squares. Okay, now we can factor each of these, and the best way is to look for the greatest common factor. Okay, so try to reduce it, and then that simplifies everything for you. So let's look at the general polynomial. And there's a caveat here. Sometimes you'll need the quadratic formula, which is the last part of our notes, and it's something that you'll be provided with in the test. So you don't have to memorize it, you just have to be able to plug everything in. Okay, so the fast method that we learned on Tuesday was to find the product of C and the sum of B. Okay, so let's do this example here. So I need it to multiply to 24 and add to negative 6. Let's write out my factors of 24. I have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Do any of those have a difference of 2? They do. I'm going to use these ones. Now I need a difference of, sorry, it shouldn't be negative 6, it should be negative 2. I was thinking of the answer in my head. So they need to add to negative 2. So then we have to make our 6 negative and our 4 positive. And we'll multiply to negative 24. So you'll have x is 4, x minus 6. Okay, now try factoring this out or expanding this and see if it is indeed correct. So when I expanded it, I found that I got x squared minus 2x minus 24, which is what I started with. And so then my roots are x equals negative 4 and x equals 6. And here, we can factor out a 3. So our GCF, our greatest common factor, is 3. So let's factor that out to make things a little bit easier for us. And that is a colon. So we'll have f of x equals 3x squared minus 5x plus 6. Okay, and then here is our a, okay, and then here's b and c. So now we want to multiply to 6 and add to negative 5. So we look at, again, our factors of 6, 1 and 6, and 2 and 3. Now both of these have can make a difference of 5, but the trick is that we need to multiply to a positive, so we need either 2 positive numbers or 2 negative numbers. And the only way this will work is if we make our 2 and 3 both negative, and then negative 2 plus negative 3 is negative 5, and negative 2 times negative 3 is positive 6. Okay, so then what we can do is we keep our 3, and we'll have x minus 2 and x minus 3, and that will be our f of x. Our roots will be x equals 2 and x equals 3. And again, if you're unsure of how we factored this, please expand this out and just double check that it is indeed correct. And now on your worksheet, you can try 7.5 part 1. And remember that the key to the worksheet will be posted. Okay, so that's if you end up with an x squared. Okay, so when we factored out the GCF, we just got x squared by itself, but we won't always have that. So if you look at this this trinomial right here, 2x squared plus 11x plus 5, we can't take any GCF out there, so we need to just work with the 2x squared plus 11x plus 5. So instead we're going to use something called grouping, and we can do grouping with every single kind of quadratic equation. You don't have to use the fast method every time. So when we group, we split the middle term into 2 terms. Sometimes this is called decomposition, and you end up with 4 terms in your equation. So again, we need to find the product of a times c and the sum of b. Again, we start at the same place. Then you group the first 2 terms and the last 2 terms. And then we factor, and we'll see that. I'll show you an example, and then you can go back and read that part. So here we want to, and just to write this out a little bit, you'd end up with f of x equals ax squared plus something x plus something x plus c. And these would both be numbers. Okay, and that's what we mean by having two x terms. Okay, and then you would group and factor, and you get f of x equals a x squared plus one of your x terms, and then you'd get your other x term plus c. Okay, and so these two together make your b of x, but you split them up. So let's try factoring this. First, again, confirm you can't get a GCF, and we can't. In this case, our GCF equals 1. So we want to be multiplying to a times c, and in that case, this will be 10. Okay, so 2 times 5, and we'll add to 11. Okay, so if we look at our terms to multiply to 10, we have 1 and 10 and 2 and 5. Now, which ones can add to 11? We'll be working with 1 and 10. Okay, so what we do is we rewrite this out. F of x equals 2x squared. Okay, and we'll then put our two x terms in there. Plus 10x plus 1x plus 5. Okay, and you can kind of just split this down the middle right now. Now look at just these two terms. What's the greatest common factor we can take out here? We can take 2x from both of them, and then we have x plus 5 left. Okay, so we'll just leave that side now. We look here. Here we have plus 1x plus 5. So this one only has a GCF of 1. We can't do anything else with that. And then we're left with x plus 5. Okay, and then with this method, you notice, hopefully, that you have two x plus 5s. So what we do with that is we take that to mean that one of our brackets is x plus 5, and the other one combines the leftover terms. So it'll be 2x plus 1. Okay, now again, if you are unsure if that is the right factoring, please multiply this out, okay, expand it, and make sure that we end up getting 2x squared plus 11x plus 5. And then our roots will be x equals negative 5, and then if we go 2x plus 1 equals 0, 2x equals negative 1, x equals negative 1/2. So our roots are x equals negative 1/2 and x equals negative 5. So let's try this one here. So again, we look for our GCF. Our GCF is 1. We're out of luck. So we have to group. So we're going to multiply to 6 times negative 10 to negative 60. And we're going to add to negative 11. Okay, so again, look at our factors for 60. So we have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. And then if I look, I don't need to go any further, because is there any here with a difference of 11? There is. I have 4 and 15. And again, I want to add to negative 11. So I need my 15 to be negative and my 4 to be positive. So then I'm going to rewrite this out. F of x equals 6x squared. I have my two terms, plus 4x and minus 15x. And how do I know which side to put them on? Well, I know that I'm going to be factoring out the GCF between the two. So I look what factors. 4 and 6 plus 4x. Both have 2 in common. And then if I put negative 15x over here, I can factor 5 out of both of these. So let's go ahead and factor that. We'll have 2x, and all I'm left over with is x plus 2. And here, if I take out negative 5, I end up with 3, sorry, just one second. So I'll have 3x plus 2. Now remember that I want both my factors to be the same here. And do I have the same? No. So I did this to show you that sometimes you have to do a little bit of trial and error. Okay, so I'm going to erase there, and then I'll put my positive 4x here and my negative 15x here, and let's see what happens. So here I can take out 3x, I have x minus 5 left, and here I can take out 2, and I end up with 2x minus 5, and sorry, my 2 is here, because 3x times 2x is 6x squared. And now I have matching brackets. So I can do 3x plus 2 and 2x minus 5. So that's my factored form, and my roots are x equals 5 over 2 and x equals negative 2 over 3. So for practice in this, try worksheet 7.5 part 2. Now again, the key will be posted, and the trick to this is to practice. So just practice and practice. It will come to you. Don't give up because you don't get it right away. Okay, so there'll be one more video, and then that will be it for the week.